David Can here with another question in topic 3.1. We're looking at an IB question about ice melting. We have a small lump of ice at 0 degrees Celsius falling to the Earth's surface. When the hailstone hits the surface, all of the kinetic energy in the hailstone is transferred to thermal energy in the ice. Calculate the minimum speed of the hailstone so that it just melts when it hits the surface. Specific latent heat of fusion for ice is 340 kilojoules per kilogram. Right, so we want to melt the ice. Now, fortunately for us, the ice is already at 0 degrees Celsius. What that means is that all we need to do is give it enough energy to melt. And that comes from the heat, the energy necessary to melt it. We call that Q, and it's going to come from kinetic energy. We can calculate the energy necessary to change state as the mass of the object times the specific latent heat, in this case of fusion, for the object. And kinetic energy is 1/2 mv squared. Now, something you probably noticed is that we're not given the mass of the hailstone. And here is why that's okay. Because the mass in Q and the mass in Ke cancel. And we can solve for the velocity without the mass. The velocity is going to be the square root of 2 times the specific latent heat of fusion for the ice. This is the square root of 2 times 340. But it's 340 kilojoules per kilogram. Kilojoules are not the fundamental SI unit for energy. They're not the standard SI unit. We need to convert that into joules. So that's 340 times 10 to the third joules per kilogram. Running that calculation, we get 8.24 times 10 to the second meters per second as the minimum speed so that there's just enough energy to melt all the ice. Part B says, with reference to your answer in Part A, suggest whether the hailstones are likely to melt on hitting the Earth's surface. Well, looking at our answer in Part A, 8.24 times 10 to the second meters per second is 824 meters per second. That's a ridiculous speed. That's almost a kilometer per second, and that is way higher than the terminal velocity of really anything falling through the Earth's atmosphere. So this is a higher velocity than any reasonable terminal velocity. So no, a hailstone is not likely to melt on hitting the Earth's surface.